Hello all, and welcome to the Automating Your Software Development with Docker and CircleCI webinar. My name is Ryan Pedersen. I am a solutions engineer at CircleCI. I'm including my links here to be shared with the webinar in case you have any questions or want to take a look at the source code. Before we jump in, a few tips, housekeeping notes. I'll do my best to make my screens as large as possible, but it always helps if you have a larger screen to use that. It also helps to maximize the Zoom window. There will be Q&A, and there is a button at the bottom of your window to submit questions on Zoom. Those questions will be answered at the end, so don't think I've forgotten about them if you ask something and I don't answer it immediately. Okay, regarding agenda for today, the presentation piece should be about 25 to 30 minutes with open-ended time at the end for questions. First, we'll spend a couple minutes on the background of Docker and containerization, then move along to Docker use cases and some terms. We'll Dockerize a React app. We'll go through some additional Docker features and add those to the React app. Then finally, we'll talk about how Docker works with CircleCI. On to the presentation. First piece on the agenda, a brief summary of Docker and container basics. Containers are container technology, a method to package an application so it can be run with its dependencies isolated from other processes. Container technology gets its name from the shipping industry. There's actually an entire book called The Box on the invention of these, but the TLDR is that instead of coming up with a unique way to ship all products, items are loaded into steel shipping containers, which are already designed to be picked up by cranes on docks and fit them into a ship designed to accommodate the standard size. To really standardize the product, keep items together, containers can be moved as a unit and it costs less to do this way. And the Docker container mirrors a lot of these benefits. Similar to that shipping container, we see Docker floating on top of the ocean, which is the operating system. It provides a vessel for containers to be packaged up code, all their dependencies, so the application runs quickly, reliably from one computing environment to another. A Docker container image is a lightweight, standalone, executable package of software that includes everything needed to run an application: code, runtime, system tools, libraries, and settings. All right, enough of the nautical illusions and on to software. So Docker is so popular because containers are a lot of things. But they're flexible. Even the most complex applications can be containerized. Lightweight, containers share the machine's OS system kernel, therefore don't require an OS per application. Portable, you can build locally, deploy to the cloud, and run anywhere. Loosely coupled, containers are highly self-sufficient and encapsulated, allowing you to replace or upgrade one without disrupting the others. Scalable, you can increase and automatically distribute container replicas across a data center. And secure, containers apply aggressive constraints and isolations of processes without any configuration required on part of the user. And there are a couple main Docker use cases that tie in very well with CI/CD that I want to touch on. If Helen of Troy was the face that launched 1,000 ships, it works on my machine was the phrase that launched 1,000 memes. Something working locally but not elsewhere could be due to numerous things. It could be leftover configuration from previous work, enables code to work on the dev environment, fails in other environments. Everyone could probably remember times that local tests pass and then fail in dev prod environments. In addition to that frustration, it's harder to reproduce errors across environments. So Docker helps make the environments across local dev and prod consistent. It increases throughput, reduces errors, all good things. And we'll talk about how that works throughout the presentation. And organizations are increasingly adopting microservices because they not only want to replace their large monolithic applications, but they also want to enable faster app deployments and updates. With monoliths, you get locked into fewer vendors. Scaling up or down means scaling the entire application. However, with microservices, you can separate your concerns and have everyone focus on a single piece. You get to pick the right tool for the right job. Docker allows you to containerize your microservices and simplify their delivery and management of those. Provides individual microservices with their own isolated workload environments, making them independently deployable and scalable. Now that we've covered off on the background, moving on to Docker files, images, containers, the fun stuff. Docker images are the basis of containers. They are a collection of root file system changes. They don't have state and they never change. A Docker file is a text file that contains all commands in order needed to build a given image. They're by default called Dockerfile, but you can name them whatever you like, and we'll go into that during the demo. They should be ephemeral by nature, and I want to highlight this because it ties really well with CircleCI. By ephemeral, we mean that container can be stopped and destroyed, then rebuilt and replaced with absolute minimum setup and configuration. And it pairs well with CircleCI because each of our jobs are also ephemeral and deterministic in nature. And the Docker image consists of the read-only layers, each of which represents a Dockerfile instruction. The layers are stacked and each one is a delta of the changes from the previous layer. And the current working directory is called the build. By default, the Docker file is assumed to be located here, but you can specify a different location with the file flag. Regardless of where the Docker file actually lives, all recursive contents of files and directories in the current directory are sent to the Docker daemon as build context. You can also build a Docker file from standard input without build context by piping a Docker file in. And then to exclude files not relevant to the build without restructuring your entire source repository, use a Docker ignore file. File supports exclusion patterns really similar to git ignore files. For information on all of these, I highly recommend the Docker docs. I'll include some links at the end of the presentation as well to the relevant pieces. Okay, now that we've gone through the basics, we'll put it all into practice. So I have a React app here that we are Dockerizing. And I'll start by getting this running locally with npm start. And before we get into the magic, I'll pull back the cloak and let you see at my sleeve. You can see there are no sleight of hands. A React app here that started with, and it's on localhost 3000. So running locally, and then 3001, nothing here. 3002, nothing there. Okay. So I'm gonna create a Docker ignore file. Put in node modules. Don't need that, it's pretty heavy. And then I'm gonna create a Docker file in the root directory. Great. Again, text file, you can name it whatever you like, by default, Docker file. Something else to note, I have a Docker extension set up for Visual Studio Code. I highly recommend doing this as well. It helps with autocomplete and just making sure that kind of a sanity check. Okay, Docker file typically starts with the from statement. Declares the base image, your new image will use for subsequent instructions. We're gonna use a node image to React app. You can specify a version or node. This, we're gonna use 14.0.0. If you don't specify a version, it will pull in latest, but for determinism's sake, we are definitely gonna specify that to control for that variable. So next, and this isn't mandatory, we're also going to add a label, doesn't count as a layer, just adding some metadata, just so folks who might come across know who the person to contact is. Next step, the working directory. This sets the working directory for many instructions that follow in the Docker file. If the working directory doesn't exist, it will be created even if it's not used in subsequent Dockerfile instruction. So we'll call this app. Right, the copy instruction copies new files or directories from source and adds them to the file system of that container at the path specified. We're going to copy over the package of package lock.json. So see the prompts there. Here's a wildcard to get both in one. These are valid in the copy instructions. Okay. Next, run, very fittingly named, runs a command inside of your image file system. We're going to do one to install node modules and the packages for the project. See the command. A lot of times the best practice, you'll want to include sudo for the run commands. You don't know the root user is going to be, and it removes a lot of errors. For this, for simplicity's sake, I'm going to leave it out, but just want to note that that's usually a good best practice. And run's a really common command. You'll usually find multiple run instructions inside of a Docker file. All right, so that would install all the node modules, all the packages you need. And currently the Docker image would just include the package and package log.json on the node modules. So we do need to add the source code. So I'll copy the source directory. Copy here, copy into the root. Okay, last to the command, a couple options. So two options here, and you'll see the prompts look a bit different. Executable is the preferred form for command and entry point instructions, although you can use bash for your command. So we'd be in general, rule of thumb, prefer entry point to command when building executable Docker image and you need a command to always be executed. Use command if you need to provide extra default arguments that could be overwritten from the command line when the Docker container runs. Okay, so we can use command for this for simplicity's sake. Okay, and that should be it. Looking back at the Docker image as a whole, each of these instructions, which we can also call intermediate images and think of as the image in that point of time in this Jenga game, are the layers that are so important to the Docker files. All right, so I'm gonna run to this. And then we're ready to build the image with the CLI. Try to save it. So my bash profile includes a Docker helper plugin, another fun plugin. It can help autocomplete and provide a guide. I'm gonna use that really, oops. Docker and hit tab, and you can see all the commands available here. So the first one I'll call out some of the ones that we're gonna use. Docker build, builds the image, which we're about to use. Pull to get the image from somewhere, Docker repository. Push to send it to somewhere, to send it to a repository or registry. Run to run the image, which we'll do in a bit. And then tag to give it a tag and a name. And the other one we're not going to use here locally is volume, but managing volumes. Okay, now building the image. We're going to run Docker build. We are going to tag this name Docker webinar demo dev and give it the latest tag and build. And this should take a minute to build. I'm going to confirm that it's running the npm install, and then we will come back to it later. So as that's building, I want to go over some of the other Docker concepts that are important to ensuring speed, scalability, and determinism while building, testing, deploying. Caching is a very important piece in containerization, both Docker specifically, as well as running Docker and CircleCI. When you run Docker build, each step creates an intermediate image. Docker steps through the instructions, and as each instruction is examined, Docker looks for an existing image in its cache that can be reused, rather than creating a new duplicate image. So for an example, we'll work under the assumption this layer has been changed since the last Docker build that we just saw here, and the requirements.txt file. Docker will look for cache hits layer by layer, pulling these layers from memory somewhere as long as they match. Then when the layer doesn't match, Docker starts building the rest of the layers. This means that to make things as fast as possible, which is great, Structure your Docker files to have the most frequently changed things as late as possible, utilizing the powerful caching feature. For our React app, this means we can anticipate the source directory would change the most, with the packages changing the least. So that's why we include the source after the packages. With multi-stage builds, you use multiple from statements in your Docker file. Each from instruction can use a different base, and each of them begins a new stage of the build. You can selectively copy artifacts from one stage to another, leaving behind everything you don't want in the final image. This results in lean images that are fast and tailored to the specific tasks that they are needed for. And I mentioned earlier that Docker will look for new layers in memory, but for another way to be able to save and persist data, and also to share between containers, Docker came up with the concept of volumes. We won't be using Docker volumes in the Docker build locally, but it will be important for CI/CD. The only understanding that we need to have going into that piece is that volumes are used to save and share data in a way outside of memory. Okay, back to the build. Great. So come back and see the image has been successfully built. It ran all the commands here. It looks like npm took about 36 seconds to install. So now that it's been locally and all the layers are stored to memory, we can expect that running it again for a new latest image will be much quicker due to caching. Excellent, really glad that worked. So we see the cache hits layer by layer here, where it's using the cache somewhere from memory. It's almost instantaneous. If I had changed something in the source code, but not dependency-wise, because the source code is down here, it still would have been pretty quick. We kick in after the heavy lifting of installing all the node modules is done. Okay, next we will run the image. By default, when you create a container, it doesn't publish any of its ports to the outside world. It'll make a port available to services outside of Docker or to Docker containers which are not connected to the container's network. Use the publish or P flag, creates a firewall rule which maps a container port to a port on the Docker host. Because our app is running locally on Docker host at 3000, we're going to use port 3001. So let's go Docker run, which we saw, 3001. By default, we specify IT, which is interactive mode. React scripts will exit once started unless this flag is present. So then Docker webinar demo, hopefully no typos. Great, starting the React scripts. Let it get up and running. Let's check to see if it worked. Should be here. Fantastic. That is also working. Another rabbit in the hat. On to some more optimizations. And the next thing we'll do is add some stages and get the app ready to be deployed. This is pretty heavy, not exactly a production ready React app, but it is good for dev. So we will create another Docker file in the source directory. Dockerfile.prod. I'm going to copy and paste this over and we'll make some changes. Move this to new. Okay. First thing we'll do is name the first stage, which is the first from statement, and we will call this build. We'll keep all of this the same. We do want the node modules. We want the source code. We don't need this command just yet because we're going to be deploying it with Nginx. So we'll take this out. And then instead, we're going to create an optimized build folder. Ultimately, this is the only artifact that we want, the result of this build folder. So this is what everything has been working towards, the leaner directory that I can cherry pick and send to the final prod layer. I'm gonna add in the next layer here. Nginx, stable Alpine, that'll work. Okay, so that's the next stage. And then we need to take the build folder that we just ran and built and copy it from the build stage to the next stage, the deployment. So that would be copy from build, it's going to be app. And I have notes over here. I don't memorize all of this, but kudos to you if you do. HTML, so that should be it. And that's where Nginx looks to deploy from. And the exposed instruction lets Docker know the containers listens on a certain port at runtime. It doesn't actually publish the port. It functions as a type of documentation between the person who builds the image and a person who runs the container about which ports are intended to be published. We're going to expose port 80, which is default for Nginx. So 80. And then we're going to run the command, which I'm going to copy and paste so I don't have any typos. Okay. And then we're going to build the image. So we're going to specify the other Dockerfile location. As I mentioned, you can title this anything. It's a text file, but by default, Docker looks for the Dockerfile in the root directory. So if that's what you want, then you need to flag it with -f. Docker build f. Docker webinar demo prod latest, and then specify the build context with a dot. And hopefully there are no typos. This shouldn't take as long because a lot of these layers will already be cached from the previous build. So what we want is that build directory and beyond. And then next, what we're going to do is run the image. So we're going to specify the port that it'll be accessible with. So we're going to use 3000 this time. 3002. Do it from 80. The Nginx interactive mode. Webinar demo prod latest. Hopefully no typos. Excellent. Let's see if it's running. Fantastic. We have the app running locally, and then containers for dev and prod also running. And now that we have as much Docker knowledge as we can handle, let's apply it to CircleCI. To set the stage, I want to clarify some of the terms that are used at CircleCI. What we're looking at here is a workflow, which is just a collection of jobs. It specifies which jobs are running and in which order. Each individual box here is its own job. They're each their own independent, ephemeral environment, spun up on the fly to your specifications and torn down after. A job consists of an executor, which is the environment, and a collection of steps and commands to be run in that environment. And there are a couple ways Docker ties into your CI/CD workflow with CircleCI. The first is that execution environment. It's defined at the top of the job, and it's the image that is the base for all of the commands for a particular job. Because each job has its own base image and commands, lends itself really well to that microservices architecture. Separation of concerns, using the right tools for the right job. And the other way developers use Docker and CircleCI is by building a Docker image as part of jobs. So when the setup remote Docker executes, a remote environment will be created, your current primary container will be configured to use it, then any Docker related commands you use will be safely executed in the new environment. The CircleCI Docker layer caching feature allows builds to reuse Docker image layers from previous builds. So image layers are stored in separate volumes. There's volumes coming back into play in the cloud and not shared between projects. So just think of that caching feature, but it's across your jobs at CircleCI. All right, now we'll go to the CircleCI and dig a bit deep, UI and dig a bit deeper into some of the concepts. Okay. A few things I want to call out with CircleCI on the workflows page here. First off, as we can see, take the same source code and apply it to different node versions. We're using 14.0.0, but if you want to test it across different node versions in a more thorough manner, we're able to absolutely do that. We're applying matrix job functionality to change that one variable to node version and keep the other things consistent. And because the entire build test deploy process is done in these deterministic and ephemeral containers, CircleCI really is controlling for everything outside of the source code. So you know if something fails, it's because of that. And if you rerun the job without changing anything, it'll fail every time. You can also expect that if you rerun a successful job, it will succeed. All of the same controls are in place. And CircleCI allows you to rerun the job from the workflow level. So you can rerun all the jobs in the workflow, or down into the job level. You can rerun something where it failed, or because everything is deterministic and the same for each run, you can also SSH into the job, see exactly what was going on and see what might work. You can expect those results to be really helpful making changes. And the other piece where Docker comes into play is building the Docker image. So the last job is building the Docker image. It does involve Docker layer caching, but because this is the first one, you can see it has really similar logs. It's building everything from scratch, building that Docker image that we created. Takes about 1:10 to actually run this piece. But if we run the job again, because Docker layer caching is enabled, excellent news. You can see the cache working really similar to what we saw locally. So you have Docker layer caching, it's instantaneous to actually get that up and running. So really powerful tool when you're building Docker images as part of CI/CD. Now that we've seen Docker and CircleCI in action, we'll wrap up some of the concepts mentioned earlier. Back to CircleCI and Docker and how the problems discussed are solved. Works on my machine use case is solved by ensuring determinism. The same input will get the same output. Less rerun jobs leads to more throughput and efficiency. And then by containerizing and splitting things up, utilizing Docker and CI/CD, we're able to solve the microservices use case. Great. As far as prepared information, that's it. Containerized a React app for dev and prod, included it in the CI/CD workflow. And as promised, we will have time for questions. And just a reminder, or in case you joined late, the Q&A button is at the bottom of the Zoom window. So I'll have to go ahead and take a look now. Okay, the first question was someone new to Docker. And I'm using, correct, Visual Studio Code. That's my IDE. And I'm using NPM. Although these instructions would all be the same if we're using yarn. So I have a yarn lock file, so I would just copy the yarn lock instead of the lock.json there. Great. Looks like we answered one other question live. All right, I have a question around tagging image. And there are a couple good options here and ways to do it inside of CircleCI that I want to touch on. Jump in. So if we look at the config here, I'm going to go into the configuration file for this. And you can see that I'm just using like CI image latest, but there are a lot of ways to powerfully and conditionally run this. So CircleCI has some options of environmental variables that are present for each job. So a lot of folks will see using the SHA to tag a certain image, but you can also create your own with what branch you're on, or like the job number. So a lot of flexibility with environmental variables that you can include inside of CircleCI and the config file. And you'd be able to just set, if you want to tag it here, I'm using the 0.1 number and then add in the SHA here to tag my image. But you could include whatever you want as far as the tag. And that would just include tag down here. Okay. Another question about SSHing into the job on CircleCI. So CircleCI is an OAuth app and we inherit the permissions of the VCS. So in my case, for this instance, I'm using GitHub. So I inherit the SSH keys and set up, and then I actually just rerun the job with SSH. it will prompt me once I get the SSH set up, and it'll give me the ability to SSH into it from a local terminal. I'll show that, and it'll just confirm that you have the correct SSH keys configured. Give this a second. While that runs, question from Raphael about running unit tests in a layer of the Dockerfile. So what I would do for unit tests and to be able to run in a deterministic nature, so you can see you can SSH in here from the terminal if I copy this. As far as like running unit tests in deterministic nature, I would ensure that the unit tests work on a step like this. I have the same base environment and I run it, and it's just more easier throughput, easier pieces in the Dockerfile after it passes these tests in the same node environment. You can ensure that it will pass. The Dockerfile is ready to go. So as long as they match in the versions, and that's why we try to give you flexibility to match the versions. I would recommend running it in like a job here with the same base and saving time on building the Dockerfile. Let's see. We have a question regarding the set up remote Docker machine true, deploying on or deploys, and I will follow up after as far as like a product roadmap, as far as like the G-Cloud versus AWS. Right, another question around the command, run, and entry point. So let's use this for instance. The run are just the basic pieces. So there should be multiple runs throughout the Dockerfile, and just executes any command that is on a new layer on top of the current image and commits the results. The resulting committed image, what it is, will be used for the next step in the Dockerfile. Whereas the last one should be the command or entry point, as far as the main one to end out the to start the image. That's why I'm running like the npm start. There's the main one that will end the image, and the difference between the command and entry point. Entry point, good for building an image where you need a command to always be executed, and command for if you need to provide some extra default arguments that could be overridden from the command line when the Docker container runs. And if you hear that and aren't sure which one to use, either are useful. So you'll really know it when you need to pick one or the other. Question from Tom around the links shared at the beginning of the presentation. We'll send this out afterwards, and I'll include these. So there will be the resources. You can see the source code, Docker docs that are relevant, and the CircleCI docs. So that will all be as a takeaway from this to everybody here. Let's see. All right, another question regarding creating multiple containers. And you specify multiple containers and the best way to interact with them. So you would probably want to just keep them in their own container. They can interact, define their containers, and you can interact with them via Docker Compose, but it's really situational. But like I'm running a couple like on Kubernetes where I have different containers, different pieces, and then they have the one concern, they're focused on one thing, doing it very well, and then they can talk to each other, do like the networking. All right, I had a question regarding CircleCI with GitHub, and then I'm going to follow up offline for some more of the specifics of this, but generally with CircleCI with GitHub and Bitbucket, really it's the same as far as like we're piggybacking the same way on for each VCS. So once a commit hits GitHub or Bitbucket, shoots us a webhook, and then we follow the instructions specified in the config file in a deterministic manner. So like side by side with the Bitbucket piece, it's definitely the same process. All right, there's a question around the Docker files and starting with the from piece. As far as like the Linux distro that's used for each from, you'd have to check the documentation. One piece I do want to highlight is that many times the piece that you want to, pieces for your, there'll be more pieces for your dev environment. And so running in CircleCI or CI/CD in general. And I think it's usually best case to use like an Ubuntu. This includes more things like libc that you can use, less errors. So you need more tools for CI and CD. Whereas like an Alpine environment for prod, you want it to be as small as possible and as fast as possible. So you can see I have the Alpine here that I end up using. And then here is really just, I believe it's the Ubuntu environment. Okay, so there's another follow-up on one of the earlier questions about using master with the CI shop. And that's a really good opportunity to use conditional workflows. So like branch level filtering and have certain jobs run only on certain branches. So if it's on, you could have a build, here are my jobs defined down here. But if I only want this to run on the master branch, I can filter it here. Let me pull up the docs for that. The docs over here. Okay, so I'm gonna go here really quickly. So you can have this job only run on master. So you ensure that a certain variant of it is running on master, or you could pass on a parameter as far as, and you can inherit that. So you can have that parameter being the branch running there. But the conditional jobs for the branch would be what I would recommend there. It just takes into standard regex and you can filter however you want by branch tag, trying to give you some flexibility. Great, we have a question around unit tests in a project, and if there's a way to parallelize their execution in CircleCI. And there absolutely is. So here we're looking at like different parallel jobs, but inside of CircleCI, you can actually in the config file define n number of containers to split it up across, and then pass in a list of the files, and we'll split it up across those containers that you defined. So it would be be like this. If I want to, it's taken me an hour to run 1,000 unit tests. I could split it up by 10 and see some pretty significant time savings inside of that single job. That's separate from jobs running concurrently. I have a question regarding something with data volumes, and I'm going to follow up offline with that. I'll make sure I understand. I'm going to include some docs around the exposed piece. Again, Docker docs are very thorough, highly recommend going through a lot of the Dockerfile reference, and then as well as some of the more out there ones. And I want to cover off on some optimization features also here. So in this workflow, I'm using a concept called orbs, which are really just reusable configuration as code. So you can use the basics of something you condense a entire job or executor command full job into a single or few lines of code with different parameters. So you might see that this job, as far as node testing, isn't defined down in the job section. That's because the orb is a full job. There's also a really good one for Docker. Let me pull that up. This is the orb directory where you can see. So you can see a lot of the Docker pieces here we already have pre-built, so you can just define your executor really simply or setting things up remotely. really robust examples of things you can do with Docker. See the build, and then you can see the different parameters that you might need. So build an update and then publishing repositories, try to make it simple. And then if you have any questions around orbs, you can also go down, take a look at the actual source code, which are listed on each of the pages. So really thorough pieces if you want to get some inspiration on ways to do things. The orb directory is also very thorough. So if you were using a different registry, like ECR, we have a full one here that's certified. Really flexible in terms of what you want to do. And plenty of orbs. So I'm using the node one here, but highly recommend using that if you're new to CircleCI or just want to simplify some things, or even if you've been on for a long time, haven't implemented them fully yet, really highly recommend. Let's see. And Daniel had a question around using the checkout inside of a Docker image. I assume that's in the base image, but correct me if I'm wrong. So I'm using the checkout here, and this checks out into the CircleCI container. And then we'll set up their remote engine to run the Docker commands in like a separate sandbox environment. So CircleCI provisions once they get the webhook and we have the job ready to go, we provision a Docker container to run everything, and then we add an extra Docker container for the Docker pieces. And I'm using a CircleCI specific Docker node image. So these are ones that we maintain. They're highly likely to be cached on the different hosts that you would spin up. Includes a lot of the base level tools that you might need. So has a few more things than the basic node image that we were just using. So it's something to keep in mind. You could also use that here in these Docker files. So if I wanted to run the CIMG image, I could certainly do that. This, oops. I could pull this one in, and the user there, and the why I mentioned sudo, you'd have to run this because it runs the CircleCI user, but should work just the same. So plenty of options for you. You can pull from a public or private Docker repository for your base image. So really anything you can do in a local Linux, Mac, or Docker environment, you can do in a CircleCI job. Actually, this should build a new. Let's see how long it actually takes. Oops. All right, so a question around a playground to learn, like trial and error system to play around with CircleCI. So we do have a free and open source tier that we recommend using. Most folks end up using our Docker executor, so really straightforward if you want to just use one of our base images, get started, get going. And we do have, depending on familiarity with CircleCI, see the projects here. And if I were to want to onboard a new project, oh, don't have any. We provide you with a basic template as far as like getting started, depending on the language you're using. So you could use a lot of actually examples in CircleCI public. I would recommend additionally. We have some other React demos here, but recommend the free tier, playing around and seeing how fast you can get things to work. because a little bit of time here, this is running the same way. Just finished that image. That's using the CIMG, but with sudo, which again is a best practice for Docker files. I just didn't want to have any typos. And really here, if you want to start pushing to a Docker repository, orbs are a really good example, as well as you can just write it. Anything you want to execute via the script or pull in custom scripts you can do in CircleCI. So you just need to log into Docker and push whatever the command is you want to do. So you're able to do all of that inside of CircleCI. Oh, and the last piece, as far as the information covered in the config that I didn't mention, that dependency graph where the build happens after is specified here. So you just set the requires key. So you know that the building the Docker image requires all the node tests to pass. You can build out a complex dependency graph pretty easily in the workflow stanza. And a question around integration tests, more complex, and is Docker the only way to create the microservices with Docker image and then run the test? And the answer is really is about your current environment and currently what you're doing. A lot of like nuances. We could typically mirror what you can do in a local environment or how you do something locally, because the local execution or its execution environment we're spinning up. So whatever makes the most sense as far as like determinism, but you'll have folks, there's like a Cypress orb, a lot of folks using Puppeteer and doing things in different ways. So yeah, microservices and containerizing and potentially using another image for your database to mirror that for integration tests definitely makes the most sense. And then a question around the CircleCI VS Code plugin. There's currently no plugin, but we do have a command line tool you could use. So if I was going to work on my config, I want to make sure it's all valid syntax. Let me make sure it is. I can run CircleCI config validate, and it'll let me know if the config file is actually valid. So highly recommend using that just by default. Even for someone who commits a lot of CircleCI changes, I still forget sometimes, and then I have to wait for a build error and then like a syntax thing. It's nice to have it back to that piece of like throughput and just getting the information back from the pipeline quicker. And I have this done with brew. So just brew, I'm using a Mac, so brew install CircleCI. we're coming up on time, and I know there might be some lingering questions. So if we can't get to those, like feel free to, again, reach out to me. I'm happy to work through anything. There's a couple follow-ups that I want to send out, so I'll ensure that I send out some individual follow-ups and maybe the more specific questions. Thanks, Dan. Appreciate it. Thanks, everybody, for your time. And hope we chat soon.